This is a video about soap. Soap is made by treating oils with a strong alkaline solution. The Babylonians already knew how to make soap almost 5,000 years ago using ashes and plant oils. Today we take soap for granted, but have you ever wondered, what is soap? What is special about it? And how does it work? Let's find out. But why do we even need soap? That's obvious, to wash away dirt. But what is dirt, and why can't we just use water to wash it away? Well, that's a good question, but to understand this, first we need some basic chemistry. If you take a substance like colored salt and dissolve it in a liquid, such as water, then that substance is called a solute, and the liquid is called a solvent. And the resulting mixture is called a solution. Almost all substances fall into one of two types, polar and nonpolar. Water is a polar solvent, and anything that dissolves in water is a polar solute. And many other substances, such as oil, are nonpolar solvents, and anything that dissolves in them is a nonpolar solute. The problem is that oil and water just don't mix, no matter how much you stir. Polar solute can only dissolve in a polar solvent, and a nonpolar solute can only dissolve in a nonpolar solvent. In other words, like dissolves like. Let's see what happens when we try to dissolve a solute in an incorrect solvent type. For a polar solvent, I can just use some water. For a good nonpolar solvent, we're going to need some help from a chemist. We're going to use hexane. Hexane is a hydrocarbon with 6 carbon atoms. It looks like water, but it is volatile, highly flammable, and must be handled with care. You already saw what happened when we mixed the colored salt with water. The salt dissolved in the water because salt is a polar solute and water is a polar solvent. Now we're going to repeat this experiment using different solutes and solvents. Now we're going to try using hexane instead of water. Salt is a polar solute, but hexane is a nonpolar solvent. And as we expected, the salt does not dissolve in the hexane and settles at the bottom of the beaker. And now we will try the same thing, but this time we will use a common nonpolar solute that you often find on your frying pan, butter. And as we suspected, the butter does not dissolve in water. And just like with the salt, we will also test our nonpolar solute with hexane. And as we suspected, the butter does dissolve in the hexane. So as we expected, when we try to mix our solutes and solvents, the salt only dissolves in water and the butter only dissolves in hexane. Like dissolves like. So why can't we just wash a dirty pan with hot water? You've probably already guessed the answer. Most dirt is oil-based, like the grease on your frying pan, and the water rolls off the grease, literally like water off a duck's back. So this is where soap comes in to help us. The soap molecule has a long nonpolar tail and a short polar head. The grease on your frying pan is nonpolar, so trying to wash it away with water is ineffective. When we add soap to the grease, the nonpolar tail of the soap molecule attaches to the dirt, forming a micellar bilayer. When we add water to the mix, the polar head of the soap molecule attaches to the water, so the soap acts like a bridge between the water and the dirt, and the resulting mixture is called an emulsion. And now we can easily wash the emulsion away with water. Looks pretty clean to me. So let's put it to the test. You think 5,000 years of technology can help us wash the dirt off this car? Let's find out.